What is a graph? And what graph are we talking about? That's typically, yeah, what we're saying, talking about a graph like that. Are there more graphs than that? Yeah, there's a pie chart. There's a histogram. There's like 7 of them in statistics alone. But what does a graph represent? Yes, what kind of pattern? What's the data point? Those are all true, but not really. It's a very ambiguous terms. But actually, a graph, pictorial representation of a mathematical equation. It's a picture that represents the function of the equation itself. Yes, all of what you guys said is absolutely true, but for one specific part. This is in general what a graph represents. Where did it come about? In the beginning. What was the first graph you learned? The number line. What was the first type of numbers you learned in elementary school? Positive numbers, or we call those natural numbers. Natural numbers are the counting numbers. The counting numbers. 1, 2, 3, 4, 5, 6, and so on and so forth. And then, what were you introduced to? Before that. Before that. You were introduced, okay, here's 1, 2, 3, 4, and so on and so forth, all the way to infinity. Then you were introduced to a whole. The next things you want to talk about are whole numbers. Okay. The symbol we use in mathematics for natural numbers is that n right there. For whole numbers, we use that symbol. The reason it's called whole numbers because it begins with a whole. 1, 0, 1, 2, 3, and so on and so forth. Now, why is 0 in mathematics? 0 was one of the most difficult concepts to understand. What does it mean? What does 0 represent? Nothing. It's but yeah, but it means nothing. Think about it in business. How would you describe 0 in business? How would you pay somebody 0? Exactly. There's nothing. But remember, all this stuff, where did algebra begin? What do you think? Algebra, which we call now algebra. It's an Arabic word. Al means from, Jabar, the region, the area, the person. And the very interesting about that, how is Arabic read? Right to left. How do we read? Yeah, so the concept we use in Arabic to what we use now is opposite directions. So the whole numbers start at 0. Okay, now in business, now we have something we talk about. If I started off with 4 cows and I gave you 4 cows, how many cows should I have left? 0 cows. Now I have a meaning, a reason for that. It's not just an empty nothing. It's now a number that represents, as you said, equality, a fair trade. Then came debtors. You owe me something. If I had 4 cows and you took 5, guess, yeah, you owe me a cow. Now we have what we call integers. That goes from negative infinity to 0 to positive infinity. So now but we weren't happy with that because if I had 4 cows and you had 5 chickens, are they the same conversion? No. So you take like 3 chickens for 1 cow or 5 chickens for 1 cow. So that means for each cow, I can put 5 chickens in there. So now we talk about, I'll say decimals right now, which are defined by what we call rational numbers. What's a rational number represent? What is a rational number? When I say rational, what does that mean? Think of the first 5 letters of rational. What's a ratio? How do you represent a ratio? A fraction. Those are fractions. So what we call them, instead of rational numbers, we call them quotient numbers, quotients. So the symbol we use for there is the Q. So what we're looking at there is between 0 and 1, we have fractions. This is 2/4. How many fractions, how many decimals are between 0 and 1? Infinite number. You could never, ever, if you looked at all the numbers, you could never get from 0 to 1. Any number you give me, I'll just put another decimal on it. So it goes on from negative infinity to positive infinity for infinity. That wasn't good enough. That wasn't good enough. Because in engineering business, we got to a place where we cannot define a number. It's a number that we calculate, but it doesn't really exist. That number we call I for imaginary. Which leads us to what we call complex numbers. Which is a C. A complex number is made of 2 parts. A real number plus an imaginary number. What's a real number? A real number is any number in that range. All of these together define real numbers. The natural numbers, whole numbers, the integers, the decimals, the quotients. Real numbers designated by that R, kind of looks like a realtor symbol. It's every number between negative infinity and positive infinity. Then what would imaginary numbers be defined as? Here's where you'd never guess. Mathematicians are not too creative. You know how they define an imaginary number? Any number that is not real. So if it's either real or imaginary, and that's it. Which is why complex numbers are made up of we have real numbers and not real numbers. So that is how you first were introduced to mathematics. That's how you were first introduced to mathematics. How does this relate to graph? Because that gave us now our axis. That gave us our first number line from negative infinity to positive infinity with 0 in the middle. Positives to the right and negatives to the left. But the reason this, think about this. When humans first moved, how do they move? Walking, crawling, running, bicycle riding, cars, horses. Everything was left and right, horizontal. And then was introduced what? We can now go above and below. Airplanes let us go higher. And submarines let us go lower. So as human evolution evolved numerically, this is what we have introduced. We first number lines, then we have north and south. And we'll give a name to this in a second. Actually, you know who invented this and why and how? Rene Descartes. Ever hear of that guy? He's a French mathematician philosopher. He's the one who came up with the phrase, I think, therefore I am. Cogito ergo sum. Cogito ergo sum. I think, therefore I am. He was sick one day. He was laid up in bed. And he looked up on his ceiling, like what we have up here. And he noticed a spider crawling on there. And he thought, interesting. Here's my bedroom. I'm looking up. Here's a corner of my bedroom right here. I can tell you exactly where that spider is by counting the number of horizontal spaces and the vertical spaces. So if the spider was over here, he can tell somebody, hey, on the segment 4-3, there's a spider. Of course, they didn't know what we were talking about. Said, so here's the corner 1, 2, 3, 4 spaces this way, 1, 2, and that's where the spider is. So you go 4 to the 5 to the left, 4 to the left, and up 2. So that was his breakthrough. He was sick and he saw that and he came up with that. That's how come we call this graph, we don't call it the XY graph. It's called the Cartesian coordinate system. And they didn't call it X and Y. They call the horizontal the abscissa and the vertical one the ordinate. What is co? When you see a prefix co, what does that mean? Correspond, corporation, coordinate. Co means with. What this means, this is a coordinate. The ordinate with something else. So that's how they define it. That was too much writing, so we said let's make it easier for us. We'll call this one X and we'll call this one Y because of the alphabet. Remember, Arabic, we couldn't do that because they don't have X and Y. They have a alif and quadruple, some other symbols. So this is the evolution where it came from. So the spider is at a point. What is a point? We use the words all the time. Now we have to know what we're talking about. What is a point? Very good. It's a location. And that's going to be very important for us when we talk about these things in a very short while. It's a location. So we have a location. Okay, there's a point. It's got a location. So what is the location of that point? Right. It's 1, 3. But how do we write it? Why is that? What's that? Well, yeah. Well, we have to know how to represent it. So the way we represent it is we have to know from this point. What is this point called? Remember, when he was sick, he started from the corner. He said, go 4 spaces this way and then 2 spaces that way. So he started from here. We'd use the word start if we were today because we're pretty much lazy and don't know big words. So what's a more impressive word than just start? When the world began, what is that called? It didn't just start. It's called the origin. That's where everything begins, the origin. So what's the location of the origin? Yeah, you don't go anywhere horizontally. You don't go any vertical. So it's 0, 0. And that looks like ooh. So we had to separate them. So location became that. It's the location. You have an X and Y component. Why does X go first? Well, because when we think about it, that's how we figured out first. We did the horizontal first, and then from there we went up. So it's always horizontal, then vertical, starting from the origin. So this one, start from here. I go 1 to the right. That's +1, and then go up 3. 1, 2, 3. What's another name for this? We don't call it point. We don't call it locations. We call it something else. Ooh, that's a good one. It's a court. That's where it came from because it's ordinate and abscissa. It's more so referred to as an ordered pair. Whenever you hear the word ordered pair, that means you know the X and Y location, the coordinates of a point. Who think all these words mean the same thing? Point, location, coordinate, ordered pair. So once we have that taken care of, we have another problem. So this one here would be what? What would that location be? How about this one? Yeah, because from the origin, you go over 2 and then down 3. And that one. Yeah, so each point has its own location, which we notice something now. Well, we have 4 parts. If you have 4 things, 4, that's quad. So if there are 4 locations, they're called quadrants. We have 4 quadrants. And they use Roman numerals to label the quadrants. Think about if we were to label today this picture, where would we start and what would it look like? If we had to define these 4 quadrants on this picture, where would we start? Which direction would we go? You start over here? No, you wouldn't, liar. No, no. I'm saying if we did it today, not the way Renee did it. We started top left and go this way. That's where we would have done it. And that reason that is because it's called what? If you go this direction. Clockwise. Well, did they have clocks back then in the 1700s? No. What do they keep time with? Sundials. Sundials work how? Where the sun rises. Where does the sun rise? From the east. Then it goes this way. And then if the moon follows the cycle. Because it starts off in the west, this is quadrant 1, this is quadrant 2, this is quadrant 3, and it finishes at quadrant 4. That's the reason it's labeled counterclockwise and not starting on the top left, top right. Because that's where it all. So we have to understand where it came from and why it came from. But yeah, you're right. This is how it's done. But had he invented it today, it looked totally different. Now, what are the important things about quadrants? We know that each quadrant is made up of different signed numbers. In quadrant 1, remember, you start from the origin. To go to quadrant 1, what do? You go to the right and you go up. Those are both positive. And you go to quadrant 2, you go to the left, negative, and up, positive. 3 is left, then down, negative, negative. And then quadrant 4, we go positive, then negative. So by looking at any number, you can tell exactly which quadrant it's in by looking at the signs. What quadrant is that one in? Yeah, because you go to the left and then you go up. So it's left and up. You're in quadrant 2. So that's the beauty, that's the ease of it. How is this stuff used? Do we have a function for this? A purpose for it? A lot. Especially when if you're moving and traveling. Especially in the old days. Remember, Rene Descartes' French. So this is Paris, middle of France. How would you get to Normandy? Well, to go to Normandy, you have to go east or west first and then north, or north then west. If you go to Versailles, then you go down and over to the right. So it helps in when it comes to movement, traveling. Which direction do you go? You follow your map and where you are, where you're going to. What else? What can we do with this? If I have a map, and now if I have a graph, what can I do with a graph? What can I find mathematically? If I have a point, what can I do with a point? Right. Nothing. It's just a point. You just admire it. It's a pretty point. What do you need to do anything with it? You need to have 2 points. Why? Because how many lines can I create going through this point? None. Okay, here's the point. I could that line, that's a 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 line. I can make infinite number of lines go through that one point. Because nothing's defining it. It's just going through that one point. There's an infinite number of lines. But once I put a second dot in there, I now have no other recourse but to follow this path. There's only one line that connects those 2 dots. So to have anything to do with a line, you need at least 2 dots. What can we do now? If we have 2 dots, what can we do now? What can we find about them? We can find out the slope between those 2 dots. What else? This is point A, and this is point B. The distance between them, very good. What else? You, you can't find the y-intercept just with just by the 2 points. You need something else to do that, but you're very close to it. We have here's 2 points. We connect it with what? A line. Do we know anything about the line? We can find an equation of a line. Once we have 2 points, we can now define the line that connects them. One more thing we can do. Think of business or practicality. If you and I are starting from 2 different points, A and B, and we want to meet in the middle, how do we find that point? What's that point called? It's called the midpoint. So think about it. So if I were to borrow something from you and you said, well, let's meet halfway, where would that be? So we look at get our map out, do this. We forgot we're going to meet exactly here. Why? Because it makes neither of us have to go any further than the other person. So this is 2 governments who are about to sign a ceasefire. Is one government go further than the other? No, we're going to meet in the middle. This is how we find it. So we begin with the first one. How would you define a slope? In words. No formulas, words. What's that? Yes, that's typically the first one, but it's half right. But what does rise mean? It's going up. Does it always go up? No. So that's why we should look at, if we do that, it's rise if the number's positive, it's sink if the number's negative. So if the graph is going up from left to right, it's rise. If it's going down, it's sink. It's going down. So this is a positive slope, and that's a negative slope. So how do we define rise and run? What's run mean? It's a horizontal. Always move left to right. Think of the x-axis as time. Can time ever go backwards? No. So the x-axis, when we talk about these things, we always read left to right. So if you look at your pencil like this, and you move over to the right, where's the graph going on your pencil? You're going up or down. So it's positive. If it's going down, it's negative. So that's a rule of thumb. This is a math course. We need formulas. Instead of the word slope, it's too many letters, we use the letter M. Now, in words, rise deals with which axis, X or Y? So it's the Y-axis. So what do we do with the Y-axis to be rise? What we're looking here is the change of Y. From here to here, what is the change of Y? And the bottom is, since it's a horizontal movement, is the change of X. It's going from here to here. Now let's make it look more mathematical. In mathematics, instead of writing the word change of, we use the symbol delta. The change of. So the change of Y over change of X. So here's the question. The change means the distance between one to the other, how far they are apart. So between 1 and 5, how far are the numbers apart? Between 2 and 35, how far are they apart? Between 12 and 97. Everybody see what they're doing? We're taking the bigger number minus the smaller. So 5 minus 1 is 4. 35 minus 2 is 33. 97 minus 12 equals 85. So we have one x value and we have another x value. So what's the distance between there? Right. That is our formula for delta x. X2 minus 5. So it's always the bigger minus the smaller. Why is that? Why do we always make it bigger minus smaller? They make it positive. Yeah, it'll be positive if it did the other way. Because if we take a bigger number minus a smaller, it's going to be positive. So what's the change of y then? If the change of x is x2 minus x1, what's the change of y? And there's your formula for mathematics for the slope. So all you have to do is define x1, x2, y1, y2. Here are points. If we look at this way, left to right, this A is actually our first point. This one is our second. Notice the subscript, the number on the bottom. It's not squared. That means P times P. P sub 2 means it's the second point. P sub 1 means it's the first point. It's a reference to its location. So since that's point 1, what is it made up of? Points are made up of what? X and Y. So if this is point 1, its X is X1, its Y is Y1. So the subscripts X1, Y1 refer to point 1. What about point 2? X2, Y2. Yeah, so those are it tells you the X value of the second point, the Y value of the second point, the X value of the first point, and so on and so forth. So what is point 1? What is location? 1, 1. What's the second point? So all we have to do for this equation, we have to label x1, x2, y1, y2. So what is x1? X1 is 1. What's x2? Y1 and y2. Once we have those, we're good to go. Plug it in there. 4 minus 1 over 5 minus 1. The slope is 3 over 4. Leave it like that. Don't convert it to decimals, because this means more to me than 0.75. Why? Because remember, what is slope made up of? Rise over run. It's a relationship. A slope is the relationship between each point on a line. So, since my slope is 3 over 4, which means I go from here, rise. If I go up 3 and then over 4, I get to my next point. I get to the next one, go up 3 and over 4. Infinitely, I get my line. So that's my first one. So tomorrow we'll do the rest of these. All right. Have a great day, everybody.